Hi guys, decomposition reactions, next classification of chemical reactions. All right, decomposition is going to look very much like the opposite of synthesis. It kind of is. The thing to know about decomposition reactions is that they usually require energy to get going. Sometimes they're very, very slow reactions. That energy could be in the form of heat or electricity. The general form of decomposition reactions, you have one compound on the reactant side. Remember synthesis, you had one compound on the product side, so this is kind of the reverse of that. So you have one compound on the reactant side, and it breaks up into simpler substances on the product side. Okay, so I'm not going to do demonstrations of these. Actually, here, I'll do the acid one. Some sulfuric acid. It's decomposing. Cool, huh? Boring. All right, so when you take an acid and you break it up, review your synthesis notes if you want to. Let's just use the sulfuric acid I did with synthesis. And that's the one I just showed you. All right, so sulfuric acid, when it decomposes, I get water and an acidic oxide. Remember, those acidic oxides are nonmetals. So that's my sulfur and oxygen. And remember, when I synthesized the acid, I took my oxygen and bumped it up by one. Well, when I decompose it, I'm going to bump it down by one. So I'm going to make sulfur trioxide. All right, so balance it. 2 hydrogens, 1 sulfur, 4 oxygens. 1 plus 3 is 4 oxygens, balanced. All right, let's do the base. So we'll take our sodium hydroxide. When that decomposes, I get a metal oxide because metals like to make cations. This hydroxide, which is an anion, makes it the base. So I get water, which is the liquid, and a metal oxide. My metal is sodium. Oxide means it's bonded to oxygen. Okay, sodium is +1, oxide is -2, so if I crisscross, metal oxides are solid. If you look at your solubility rules, same with nonmetal oxides, if you look at your solubility rules. Okay, balance it. 2 sodiums, 2 sodiums. 2 oxygens, 1, 2 oxygens. 2 hydrogens, done. Okay, now, the next two, I'm going to do demonstrations for. So I'm going to talk about them, and then I'm going to do both demonstrations just because I have to turn the camera. It's just going to be easier. All right, so the first one I'm going to do, I'm going to take some plain sugar, table sugar, which is C12H22O11, and it's solid. And I'm going to decompose it. What am I going to get? Carbon and water. Okay, I'm going to show you that one. And while I'm showing it to you, or afterwards, we can work on balancing that. All right, oxides of metals. So let's take rust. Let's take iron 3 oxide. Iron oxides are solids. It's going to decompose, and it's going to give me iron. Oops. And oxygen gas. Okay, so I'm going to let you work on balancing that one as well. I'm not going to do that reaction for you. We had a rusty nail here, but the one I am going to do for you is one of my very favorites. I'm going to take hydrogen peroxide and I'm going to decompose it. When you decompose hydrogen peroxide, you get water and oxygen gas. Okay. And this is why when you buy hydrogen peroxide in the store, you buy it in that brown bottle, because it can decompose so easily that just light will make it decompose. My hydrogen peroxide I'm going to use comes in a white bottle, which also keeps the sunlight from hitting it, so it keeps it from decomposing naturally. When you buy hydrogen peroxide from the store, you should buy small bottles because you don't want it all to be decomposed a few months later or a year later, pull it out and want to use it. Should be okay, but me. Okay, so I'm going to turn the camera, and once again I'm going to do this reaction and this reaction. While I'm doing it, while I'm getting this ready, you guys can balance those three reactions. Oh, turn, come on. All right, there we go. I'm just going to put it there. Oops, I got to go a little further. Okay, that should work. All right. So the first one, here's my sugar. This is my organic compound. Oh man, it's going to take me forever to get all that sugar. Should use a smaller beaker. Okay. And I'm going to add a little water. Remember how I said I needed, a lot of times you need something to get this reaction started? Well, I'm going to use kind of a catalyst here to get this reaction going, and water is part of that. A little more sugar. All right. Now, catalyst I'm going to use is sulfuric acid, just because that one will break up those bonds a lot quicker. Okay, so you can see something is happening. I'm getting a color change. Get that acid down there into the sugar. All right, so I get carbon, that's what the black stuff is, and water. This is a very exothermic reaction. It's so exothermic that the water comes off as water vapor in the form of steam. Wash the acid off my hands. All right. Cool, huh? So this is carbon. You can tell it's black. It is solid. And this is real hot. Still see the vapor coming off. Okay. So let me get this one out of the way. All right, next one is decomposition of hydrogen peroxide. Okay, so I'm going to use some soap because this one, remember when I said anytime you make water, it's very exothermic process? Okay, so I just made water there. It's exothermic. I'm going to make water over here as well with this one. And there it produces oxygen. So it's making heat and oxygen. So what better way to show that than throw some bubbles in there to show you that oxygen. Okay. Also need a catalyst. The catalyst I'm going to use is potassium iodide. And I'm going to make it a solution. Okay. All right. See? Nothing yet. All right, now when I put in the hydrogen peroxide, my catalysts will help it to decompose quicker, and I will make heat, water, and oxygen. Fun stuff, huh? Okay, so can you see the water vapor? And the oxygen is combining with the soap to make all the bubbles. Now you see why this is one of my favorites. Okay. So let's go on and see if you balance these equations. Oh, you didn't get a real good view of that one. Let me show you there. There it is. All right. Going back over here. Ooh, come on. All right. Okay. I think I'm good. Nope. I think I'm good. Tish more. All right. So let's balance these. Let's see. Well, I noticed that I've got 11 oxygens here. And so let's see what happens if I put 11 here. 12 for the carbons. Carbon is all by itself, so I might be good with putting a 12 there. Now, 12 carbons, 12 carbons. 22 hydrogens, 11 times 2, 22. And then my 11 oxygens, so it's balanced. All right, did you balance this one? 3 and 2, so I've got to make those an even number. So if I put 3, 2 there, then I have 6 oxygens, 4 irons, 4 irons. That's good. Okay, now let's look at this one. So once again, I can see that I've got 2 oxygens and 1, so I've got 3 oxygens, an odd number on the product side, an even number here. So I've got to put a 2 there to make my oxygens even. That gives me 4. Well, then I put a 2 here. So now I have 2 times 2, 4 oxygens, 2 oxygens there, 2 oxygens there, 4 oxygens, 4 hydrogens, I'm balanced. Okay. The last couple types, I'm not going to show you reactions, but I am going to just go through them. So, carbonates. If it's a carbonate, that means that it's something bonded to carbonate. So I'm just gonna, let's just go potassium carbonate. Okay, so if I have potassium carbonate, do you remember when, I don't remember which video, I told you if you have carbonate on the reactant side, you automatically put carbon dioxide on the product side. And then what do I have left? An oxide. An oxide is a metal bonded to oxygen. My metal here is the potassium bonded to oxygen. That's going to be solid. Oxide is -2, potassium is +1. All right, so those are the products. Balance it. 2 potassiums, 1 carbon, 3 oxygens, 1, 2, 3 oxygens. It's balanced. Okay, chlorates. So chlorates mean that you have a metal bonded to chlorate, the polyatomic ion. Polyatomic ion, polyatomic ion. Let's do calcium. Oops, carbonate. Yes, silly. I meant to do chlorate. Okay. So when a chlorate decomposes, I get a chloride salt. So a chloride salt is going to be, that means I'm going to have chloride bonding to a metal. So I've got my metal here. I did slide that all over. Calcium is +2, chloride is -1, and that's a solid because that came from a solid over here. And then oxygen gas. Okay, so when a chlorate decomposes, you get a chloride salt and oxygen gas. Now let's balance it. I've got 6 oxygens on this side, so I'm going to have to put a 3 here, then that gives me 3 times 2 or 6 oxygens on that side. I have 1 calcium, I have 2 chlorines. Because of that 2 outside of the parentheses, I have 2 chlorines, so it's balanced. The last one, nitrates. So let's use magnesium, because I used magnesium earlier. Okay, so when you have nitrates, remember nitrate is a polyatomic ion, you're going to get nitrite. So I'm still going to be bonded to magnesium, but it's going to change from nitrate to nitrite. Nitrate is NO3, nitrite is NO2. They both still have a -1 charge, and magnesium is +2, so I still need my parentheses and 2. And I'm going to get oxygen gas. Okay, let's balance that. 1 magnesium, 2 nitrogens, 2 nitrogens, 6 oxygens. This is 4, 5, 6 oxygens. Balanced. Decomposition reactions.